Dear students, today's topic is oxyacids of chlorine. Myself, Dr. Digna Varghese.
Oxoacids or oxyacids of chlorine. First one is hypochlorous acid or chloric acid, in which the oxidation state of chlorine is +1 and the molecular formula is HOCl. It is a weak monobasic acid. It can only exist in aqueous solution, and the ionization in aqueous solution of hypochlorous acid is given here. HOCl in water giving hydronium ion and OCl minus ion. So it can donate only one proton. So it acts as a monobasic acid. It has an angular structure HOCl and the chlorine atom to be in a state of sp3 hybridization, and the bond angle is 103 plus or minus 3 degree approximately, and its bond length is OCl is 169 picometer and OH bond length is 97 picometer. Chlorine atom is connected to oxygen only, so it has an sp3 hybridized state. Structure of HOCl or hypochlorous acid. Central atom is chlorine and chlorine atom to be in a state of sp3 hybridization. The chlorine atom, the ground state having the outer electronic configuration is 3s 2 3p5, and here the half-filled configuration in the ground state. So it has connected to the oxygen atom and forming a sigma bond. This 2p orbital of the oxygen atom connected to the hydrogen atom and forming the structure HOCl, having bond angle approximately equal to 104 degree. In this chlorine molecule, chlorine atom has a 3 sp3 hybridized lone pair. Okay, 1 2 3, that is shown here. Next one is chlorous acid, that is also known as chloric 3 acid, in which chlorine is in the +3 oxidation state and the molecular formula is HClO2, and it acts as also a weak monobasic acid. It exists only in aqueous solution. In the ionization of HClO2 is given here, that is HClO2 plus water giving hydronium ion and ClO2 minus. So it can donate only one proton to this, so it acts as a monobasic acid. The structure by the chlorine ground state is shown here, 3s2 3p5, and for the excitation for the excitation state, that is 3s2 3p2 3p4 3d1, and two oxygen atoms are here, HClO2. The chlorine atom is connected to two oxygen atom and one forms S3p sp3 hybrid orbital to p orbital of oxygen and forming a sigma bond, and the other one sp3 hybrid orbital of chlorine atom to another p orbital of oxygen atom, forming other sigma bond, and there is one pi bond between chlorine and oxygen, that is by the d orbital of 3d orbital of chlorine atom and to the 2p orbital of oxygen atom and forming a d pi p pi bond. and sp3 hybrid orbitals forming 2 sigma bonds with 2 oxygen atoms and 1 pi bond with 1 oxygen atom, and there is 2 lone pairs, one is this and one is this, and here the one hybridized sp3 orbital can form a sigma bond from sp3cl and a p oxygen atom or the oxygen atom, and forming a 2 sigma bonds here, and 1 pi bond is formed between the d pi p pi bond, and the structure is like this. Chlorine is attached to 2 oxygen atoms. One is forming a sigma bond only and the other one is forming sigma and a pi bond, and there is 2 lone pairs of, and the structure is shown in this figure. Next one is chloric acid, that is also known as chloric 5 acid, in which the chlorine atom is in the +5 oxidation state. It is a strong monobasic acid. It exists only in aqueous solution, and the ionization of HClO3 is given as HClO3 in aqueous solution giving hydronium ion and ClO3 minus. So it acts as a monobasic acid. Only one hydrogen or a proton is donated to aqueous solution. The acid undergoes disproportionation reaction yielding perchloric acid, and HClO3, that is the reaction is chloric acid undergoes disproportionation giving perchloric acid. Chlorine, sometimes we will get chlorine dioxide instead of chlorine, and oxygen and water. Okay. And the structure of chloric acid, that is the chlorine ground state is 3s2 3p5, chlorine excited state is 3s2 3p3 3d2, and the oxygen atom has 2s2 2p4, and the hybridized state is sp3 having one lone pair, and it is connected to 3 oxygen atoms and forming 3 sigma bonds, and unhybridized 3d2 orbitals containing attached to or undergoes sidewise overlapping with the 2 oxygen atoms and forming d pi p pi bonds, and the structure is pyramidal. Here the chlorine attached to the 2 oxygen atoms and forming 2 sigma bonds and 2 pi bonds, and here 1 oxygen atom and forming 1 sigma bond, and the molecule contains 1 lone pair on the central atom. Perchloric acid is also known as chloric 7 acid. That means in this chlorine is in the +7 oxidation state and its molecular formula is HClO4, and it acts as a very strong monobasic acid. It is the most stable oxo acid of chlorine. It is a colorless, oily, hygroscopic liquid. Its ionization in aqueous solution showing it acts as a monobasic acid, and HClO4 in water giving hydronium ion and ClO4 minus. It decomposes as chlorine dioxide, water and oxygen. Its structure is of the perchloric acid is in which the chlorine is the central atom and has a ground state configuration 3s2 3p5, and the chlorine has the excited outer electron configuration 3s1 3p3 3d3, and it is combined or overlapping with the oxygen atoms, 3 different oxygen atoms, and forming 3 sigma bonds and 3 pi bonds, and the hybridization for the chlorine atom is sp3 It is connected to 3 oxygen atom and it is connected to 3 oxygen atom through d pi p pi bond, and the structure is tetrahedral. In this, chlorine is connected to 4 oxygen atom. Okay, in this, one oxygen atom is here also, that can forms only sigma bonds. Here only sigma bonds, and here also sigma bond, here also sigma bonds. These 3 oxygen atoms can form pi bonds with a d pi p pi bond, and the structure is like this, that is tetrahedral structure. A comparison of the acidic strength of the oxoacids of chlorine. Acid strength of oxoacids of chlorine increases with increase in the oxidation number of chlorine. That is, perchloric acid is highly acidic than chloric acid, than chlorous acid, and then hypochlorous acid. The oxidation state of chlorine in different oxyacids is shown in the table. That HClO having +1 oxidation state, in HClO2 chlorine has +3 oxidation state, and in chloric acid it has +5 oxidation state, and perchloric acid it has +7 oxidation state. The order of the acidic strength of the oxoacids of chlorine may be explained on the basis of relative stability of its conjugate bases that results after the proton removal in accordance with the following ionization equilibrium. That is, the conjugate base is formed by the ionization reaction. The perchloric acid is undergo hydrolysis in giving hydronium ion, so it acts as a monobasic acid, and conjugate base ClO4 minus. So the order of acidic strength of the oxoacids of chlorine may be explained on the basis of the stability of the conjugate base. The greater the stability of conjugate base, that is shown generally here ClON minus, the lower will be its basic strength. If the stability of the acid or conjugate base is high, the stronger will be the acid, the stronger will be the acid. This is because the conjugate base of a strong acid is weak. Okay, and vice versa. If the conjugate base is stronger, the acid will be weaker. The stability of the conjugate bases is in the order, that is in the same order as that of the acid, that is ClO4 minus greater than ClO3 minus greater than ClO2 minus greater than ClO minus. The basic strength of the conjugate bases decreases in the order. The reverse is its order, that is ClO minus greater than ClO2 minus greater than ClO3 minus greater than ClO4 minus greater than. And here the stability is directly proportional to the strength of acid, that is stability of the conjugate base is directly proportional to strength of acid. We can say basic strength of conjugate base is inversely proportional to the strength of acid. The acidic strength of acid increases in the order HClO4 greater than HClO3 greater than HClO2 greater than HClO, and among the oxyacids of chlorine, perchloric acid is the most strong acid and the hypochlorous acid is the least strong acid. Next topic is oxoacids or oxyacids of halogens. Oxoacids of halogens, due to high electronegativity and small size of fluorine atoms, fluorine forms only one oxoacid, that is hypofluorous acid HOF. And the table shows different kinds of oxyacids of halogens. First one is fluorine, which shows hypofluorous acid, and oxidation state of fluorine is -1, other one is +1 oxidation state, because fluorine is the most electronegative element. And in the case of halous acid, that is the one is hypochlorous acid HClO2, having the oxidation state +3 here, and halic acid having oxidation state +5, and chloric acid, bromic acid, iodic acid forms. Perhalic acid oxidation state is +7, perchloric acid, perbromic acid, periodic acid. Periodic acid is also known as metaperiodic acid, and other oxyacid formed by the iodine is orthoperiodic acid. It has the formula H5IO6. We can summarize the oxides of halogens and oxyacids of halogens. In our syllabus, oxides of halogens, only specified oxide is chlorine dioxide, and its structure is angular. And the different oxyacids of chlorine, and it gives hypochlorous acid, chlorous acid, chloric acid, and perchloric acid. Among them, the most stable and most stronger acid is perchloric acid, and the least one is hypochlorous acid, according to the oxidation number of chlorine and also the stability of the conjugate base. Thank you for your attention and interest.